Well, I've been doing it a little bit more longer and more often than you have. But it's still okay. You got the points, right? The points are what we need, so it's no big deal. Okay, we're going to learn a couple of new vocab words today, right? They're pretty easy, okay? The word is local minimum and local maximum, okay? So let's break it down. What's local mean? Near. Other words that local means? Hey, y'all, wake up. What's local mean?
Community.
Community, near, close by, around, right? Okay, it means something that's like nearby, okay? And what's maximum? The most, okay? On a graph, it's the highest, okay? What's minimum? All right, the least or the lowest, exactly. So we're looking for the local maximum and the local minimum on here, okay? So what point on here would you think would be the maximum or the local maximum? I heard Araceli say it. Anybody else? What point would you think it would be? This one? This one? This one? All right, that one, right? Okay. -1, 3. Okay. It's not the highest point there is because we know that over here on this end of the graph, it goes up higher. But this one is higher than all the ones around it. Okay. The local maximum and the local minimum are turning points of the graph. Okay. So this will be our local maximum. And then what would you think then? What could be your local minimum? Right, it has to be a turning point. That is the lowest one we can see. 2, 0, right? It's a turning point right here. It's also the x-intercept, right? Okay, which it happens to be more than one thing. But yes, it's our local minimum. Right, on this graph, there's one local maximum and one local minimum. But like there can be fewer or more than that. On a parabola, okay, if it's just squared, it only has either a maximum or a minimum. Okay, I know we talk about that a lot in Algebra 1. Okay, if it's a quartic graph, it looks like an M, it could have 2 maximums. Or if it looks like a W, it could have 2 minimums. Okay, so there's more than one on each of these. I mean, there's different amounts there can be on each of these. Okay, but on a cubic function like this, it only has 2 turning points. One is a maximum, one is a minimum.
Yeah.
Okay, got it? Okay, let's go ahead and write a little definition here. Okay, local maxima and minima, which is a plural of minimum and maximum, are turning points. On the graph. Because again, they're not the highest point ever on the graph or the lowest point ever because yeah, this point is below that one, but it's lower than the ones around it and it's a turning point. Okay, it's lower than these all around it. It's the one, the nearby minimum, the nearby maximum. Any questions on that one? Okay, pretty straightforward, right? Now, number 2 is going to be this graph. Again, we're going to glue it in later. Just put it in here where it's going to go. We're going to write some stuff out here. Okay, this one, they give us an equation, and they give us the graph. This one only goes up to -8 and +8. Okay, but I want you to do what we did on number 1. Okay, put it in y equals, get all your points here. I would say there's 5 points that you can put on the graph. And then graph it and point out your local minimum and your local maximum. Okay. Again, you're putting it in y equals, okay?
What do you want, Michael?
Remember to continue on past the other points, okay? Remember to continue on past the other points. I would do 0, 1, 2, 3, 4. Personally. I would do 0, 1, 2, 3, 4. I would give 5 points. 0, 1, 2, 3, 4. Then put them on this little graph.
That's why you got a good system.
I would choose any that would fit on the graph, so like between 8 and -8. So like since -15 and 21 are too big, I would pick all the ones in between. That's how I chose. First one was asking how did I know which points to choose? Because I would choose the ones that are not too big.